The topic we will be discussing is the second part of Is Matter Around Us Pure chapter, and the topic is separation techniques. Now, most of the natural substances are not pure. They are available in the form of mixture. They all needs to be separated to obtain the individual components from a mixture. But due to their difference in physical state and chemical behavior, the components have special technique. So they needs to be separated with that special technique from the given mixture. So let us understand what are these separation techniques and what kind of separation techniques can be applied to what kind of mixtures. Let us study in detail. Here we have a list of 8 separation techniques. So let us understand what are those. The first one is evaporation, the second one is centrifugation, the third one is chromatography, fourth one is sublimation, fifth one is distillation, sixth one is filtration, seventh one is separating funnel method, and the eighth one is crystallization. So we will be studying in detail about all those separation techniques today. Let us start with evaporation. Evaporation. We have already studied what is evaporation. It is a process of converting liquid into gas. So it is generally used in the separation of volatile component from its non-volatile solution. That means if there is a solution in which one can be easily volatile, then it can be used. For example, separation of dye from blue or black ink. In the figure you can see that we have an apparatus in which watch glass is fixed. We have the mixture of dye, blue black ink. So what we do is when we heat the mixture, the dye gets separated from blue or black ink because all the liquid particles from blue or black ink gets evaporated and the remaining residue is the dye. So from this method, we can easily separate dye from blue or black colored ink. Let us move on to the next separation technique. Centrifugation. The process in which denser particles are forced to the bottom, making the lighter particles stay at the top when spun rapidly is called centrifugation. This process requires spinning of the mixture rapidly. So generally before spinning, the solute and solvent particles are uniformly distributed in the mixture. So when we are spinning, what happens is the lighter particles from the mixture collect at the top and the heavier particles collect at the bottom. So in this method we can easily separate the things or the components from the mixture. Let us see what are the applications of centrifugation. It is used in dairies and home to separate butter from cream. It is also used in diagnostic laboratories for blood and urine tests. It is also used in washing clothes or washing machines to squeeze out the water from wet clothes. So these are the applications of centrifugation. Also, we have an example, that is separation of cream from milk. Cream being lighter stays at the top and the milk settles at the bottom. So in this way we can separate cream from milk. The next separation method is chromatography. It is used in the separation of those solutes which dissolve in the same solvent. The component which is more soluble in water rises faster, and in this way the colors can be easily separated. You can see the figure that starting we have just ink in the starting, but at the end we can see that many colors are coming from the ink and the one which is more soluble is at the top. You can see the yellow color in the figure getting at the top. That means that is more soluble in water, and the color which is less soluble in water is at the bottom. Now let us see where this process of chromatography can be used. In the first process, it can be used to separate colors in a dye. We have already seen that dye is a mixture of so many colors. So if we want to separate all the colors from the dye, chromatography can be used. To separate drugs from blood. During blood test, if we want to separate drugs from the blood, chromatography can be used. It is also used to separate pigments from the natural colors. The next separation technique is sublimation. Generally, we know that sublimation is a technique of converting a solid directly into gas without converting into liquid. So, it is generally used to separate the mixtures that contain a sublimable volatile component and a non-sublimable impurity. So with this process, what happens is the sublimable component converts into gas and the non-sublimable stays at the bottom. For example, we can separate ammonium chloride from the mixture of common salt and ammonium chloride because ammonium chloride is a sublimable one and common salt is non-sublimable. So ammonium chloride is collected at the top in the form of gas. You can see the figure that over the inverted funnel we have placed a cotton plug, and when we are heating the mixture, all the sublimable ammonium chloride in the form of gas is collected over the funnel and the remaining salt is stayed at the bottom. Let us understand the next technique. The next technique is distillation, the process in which two miscible liquids are separated that boil without decomposition, having sufficient difference in their boiling points, is called distillation. That means if there are two miscible liquids and they have different boiling points or they have sufficient difference in boiling points, they can be separated with the help of distillation. Okay, so there are two types of distillation generally. The first one is simple distillation and the another one is fractional distillation. Let us understand both the methods in detail. The first process is simple distillation. So generally, when the difference in the boiling points of the two components in the mixture is greater than 25 kelvins, the process is called as simple distillation. So generally, if the difference in the boiling point is greater than 25 Kelvin, we use simple distillation. For example, if we want to separate acetone from water, we can use simple distillation. Why? Because there is a difference of more than 25 Kelvin in the boiling points of acetone and water. Now the second one is fractional distillation. When the difference in the boiling points of the two components in the mixture is less than 25 Kelvin, the process is called as fractional distillation. That means if the difference in the boiling points is less than 25 Kelvin, fractional distillation is used to separate the components. For example, if we want to separate the different fractions from petroleum, that is diesel, petrol, crude oil, all these we have to get. So we know that all these particular materials have boiling points less than 25 Kelvin. The difference of the boiling points is less than 25 Kelvin. So we need to use fractional distillation in order to separate them. The next method is filtration. It is used to separate solids from liquids or gases using a filter medium that allows the fluid to pass through but not the solid. So using a filter paper from in the laboratory, we can easily separate the solids from liquids or gases because filter paper does not allow solid to pass through it. For example, separation of sand from the mixture of sand and water. So if we are mixing sand and water, so we can easily pour the mixture into the filter paper. We can see that sand is collected on the filter paper and water is passed through it. The next separating method is separating funnel method. It is used in the separation of two or more immiscible liquids having different densities. So what happens is, here we have an apparatus. When we pour the mixture of the liquid, because the liquid will have the different densities. The liquid with higher density is collected at the bottom, whereas the liquid with lower density lies at the top. And if we leave the mixture undisturbed, we can see that the higher density one is collected at the bottom and the lower density one will be collected at the top. For example, separation of oil from the mixture of oil and water. Since oil is less denser, oil remains at the top and water, being more denser, is collected at the bottom. So in this way, we can separate the components using separating funnel method when the liquids are having difference in densities. Now the last method of separation is crystallization. It is generally used in the separation of solids in the form of crystals from its solution. Generally, if we want to obtain the solid from its solution in the form of crystals, so crystallization is used. Now, what are the applications of crystallization? Let us know. If we need to obtain salt from seawater, crystallization is used. Generally, we know that seawater is a mixture of salt and water. So, if we need to obtain the salt, we need to use crystallization. Or even if we want to separate crystals of alum or fitcari from an impure sample, crystallization is used. This process is carried in 4 steps. In the first step, the impure sample is mixed with water. In the second step, the solution is heated firmly until all the water content is evaporated. In the third step, we can see that only the solid content or the salt is left behind, and the fourth step, it is allowed to cool for some time so that it can become crystal. So if we want to obtain something or some solid out of a solution in the form of crystals, we use crystallization process. So these were the 8 separation techniques which we need to discuss in today's class. So we have discussed, and please take this video seriously, go through it nicely so that you can easily solve the assignments for tomorrow. Okay? Hope the class was fruitful and the concept is clear. So from here, I am signing off. Thank you so much, students.